Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. Just in case you're for the first time over here, welcome to the channel. And if you don't know me, I go by the name Striver in the programming community. If you want to check me out, you can definitely check me out on LinkedIn. I'll be leaving my LinkedIn, Twitter, Instagram, Telegram, all the social media handles in the description below. So without wasting any time, let's get started. So Take You Forward is a full-fledged interview preparation website that I run on my end. So if you're someone who has 3 months to like 6 months of time left for interviews, I will definitely ask you out to check this Strivers SD sheet. Trust me, this is one of the most followed resources in the country as of now. What does this resource gives you? It gives you 191 well curated problems such that all your DS algo concepts will be covered. But only prerequisite is you should be well versed with the basics of DS algo in order to start with. Now, if you're someone who's a beginner, you can definitely check out our Strivers A to Z DSA course or sheet. Now, over here, what I've done is I've curated 455 steps. Every step has been curated properly, and you will get all the problem links, everything. Imagine you open dynamic programming, you want video, you get videos for everything. So, all the hard topics have been covered. You'll find videos for all the hard topics. Now we will be starting off to cover all the basic topics. So this is the video where we will be starting to cover from the step 1.1. In case you have doubt about the credibility, you can go to our LinkedIn page and you can check out all the success stories, or you can follow me on LinkedIn and you can see how many people do tag me. And also you can check out our Instagram story highlights. So if you go to Instagram, there is a highlight as success stories. Over there, you can check out all our success stories. Like there are thousands and thousands of success stories of the Strivers SD sheet. And now we are starting off with Strivers A to Z DSA course sheet, which is for beginners or intermediate level people. Today we will be covering the step 1.1, that is things to know in C++, Java, Python, or any language. Now, in order to start off with data structures and algorithms, you have to pick up any one language. It can be C++, Java, Python, or JavaScript. And you have to code in that language. Make sure you master one language. Now, in the previous video, I've already talked about C++ versus Java, so you can definitely check out that video. So in this video, I'll be telling you about C++, and I'll be covering all these basic stuffs related to C++. And in the next video, we will be covering the Java one.
आप लोग सोच रहे हो ना कि क्या ही लाइफ जी रहे हैं भैया, तो यार आप लोग भी जी सकते हो. मतलब पढ़ाई तो करना है तो पढ़ाई कर लो यार. तो अगर आपको क्यूरेटेड रिसोर्सेज नहीं मिल रहे, स्ट्रक्चर्ड पाथ ऑफ लर्निंग नहीं मिल रहा है, आई थिंक यू शुड डेफिनेटली चेक आउट कोडिंग निंजास. बिकॉज वेब डेवलपमेंट हो गया, डेटा स्ट्रक्चर एल्गोरिथम्स हो गया, इंटरव्यू प्रिपरेशन हो गया, मशीन लर्निंग हो गया, कोई भी चीज आप बोल लो, कोडिंग निंजास कम्स अप विद द बेस्ट क्यूरेटेड एंड स्ट्रक्चर्ड पाथ ऑफ लर्निंग. उनके कोर्सेस में, हर कोर्सेस पे जो भी वीडियोस होंगे, अगर असाइनमेंट्स भी दिए हुए हैं, उस पे भी हिंट सॉल्यूशंस आपको मिल जाएगा. तो यू शुड डेफिनेटली ट्राई देम आउट. जो बेस्ट चीज मुझे कोडिंग निंजास के बारे में लगती है, लाइक ऑनेस्टली व्हाई डू आई प्रमोट देम, द रीजन इज उनका सर्विस. आई फील अगर आप कोई चीज को पे कर रहे हो, यू डिजर्व दैट सर्विस, एंड दैट इज वेयर कोडिंग निंजा स्टैंड आउट. लाइक उनका जो टीचिंग असिस्टेंट सर्विस है, भाई साहब, मैंने बहुत लोगों से बात किया है. अगर आप एक डाउट रेज करते हो, दैट गेट्स रिजॉल्व विद इन 10 to 15 minutes, एंड इससे बेटर कोई चीज नहीं हो सकता. क्योंकि आप जब पढ़ाई कर रहे हो, यू नीड समवन हु रिजॉल्व्स योर डाउट लाइक विद इन अ सेकंड. एंड अगर आपको यकीन नहीं हो रहा, यू कैन डेफिनेटली चेक आउट देयर गूगल रिव्यूज एज वेल एज फेसबुक रिव्यूज. कंटेंट के बारे में आई थिंक कोई शक होनी नहीं चाहिए, क्योंकि जो कंटेंट है वो बनाया गया है जो कि इंजीनियर्स है, फेसबुक, Amazon, गूगल के इंजीनियर से ही कंटेंट ये लोग बनाया है. तो कंटेंट इज टॉप नॉच, द सर्विस इज टॉप नॉच. अगर आपको एक्स्ट्रा डिस्काउंट चाहिए, देयर इज अ लिंक इन द डिस्क्रिप्शन. मेक श्योर यू चेक देम आउट.
I'll be using VS Code in order to code. I'll be writing my C++ code over here. I'll be giving the input over here. And whatever the code generates as an output will be produced over here. So before starting this C++ video, I love to mention 2 points. First is, please make sure you watch the video till the end. You might be knowing C++, but there are a lot of things that I'll be covering in this video which you might know, or you might like find it very interesting. So make sure you watch the video till the end. The second point is again very important. When you're learning something for the first time, do not dig deep too much into certain things, because what happens is when we start off, we start to think that okay, every certain thing we'll learn in depth, and eventually we are stuck in the beginning process and we do not move ahead. So what I'll recommend you is first learn the basics and do not dig much. And eventually, when you'll go from beginner to intermediate to medium and then to hard, you will, on this flow, you will be learning everything in depth. But during your start, do not dig deep so much. Why? Do not do a lot of why. It is good to do, but there are certain things where you should not do a lot of whys, because that will be not required in the longer run. So the first thing in order to write a C++ code is the skeleton of C++ code. Now, the skeleton of C++ code stays constant across all the programs that you'll be writing in C++. Now, something like hash include. So we write hash include. Now imagine the first program that we will be writing is to print our name. So the skeleton states, okay, you have to print. You have to probably print something, which is you have to give an output, or let's say you have to take an input. So in order to take an input or take an output, we have to use this particular library. Now, as I said, do not dig deep. You don't have to know what is inside this library. Yes, if you want to know, it is okay, but you don't have to remember this. So if you use this library, this allows you to take input and produce an output. And in order to use this library in C++, we can use the hash include. So hash include IOStream. Imagine if you want to use something like a mathematical function which exists in the C++ library, then you have to use something like a math.h. I'll be talking about mathematical functions afterwards. In case you want to use something like a string, then you use hash include string. So whatever library you want to use, you have to hash include it. You don't need to know what is inside the library. As I said, do not dig much deep. And then you say int main. And then you say return 0. So this is the generic skeleton of the code. I'll remove this couple of hash includes because as of now, we are just going to print. So this is the generic skeleton of a C++ code. After this, I said I'm going to print my name. So I'll be like cout. So when I write cout, it means you have to, that allows you to give an output. Okay. Now, in order to use cout, you have to write std and double colon. So cout is a function which exists under the std. Okay. So you have to say std, can you give me cout? And then two lower than signs. And then double quotes if you're printing a string, and you can say, hey, striver. And then you can give this. So what I'll do is I'll go and run this. So the moment I run this, you see in the output screen, we have, hey, striver. So in case you want to again print this, so go across and copy paste the same line and again run this. So what happens is, hey, striver is printed 2 times, but they are printed on the same line. In case you want to print them in different lines, you can go ahead and give a \n, and you can just, so the moment you compile this, what happens is the \n goes across and prints it in the new line. So very simple. Can we use something else? Yes. Instead of a \n, we can take std and l, and we can again compile. So if we compile, endl is similar to \n. Endl or \n takes you to the next line. But usually people use \n because it is faster. Okay. But you will find people using both. So it is your choice. If you want to print something on the same line, you can again print something like hey Raj. You can again print, and again you can give something like endl. So there is no limitations on the thing that you want to print on the same line. You can print as many things over here on the cout, and that will be printed according to the functions that you give. Like over here, you give an endl. So that is why hey striver, hey Raj, and hey striver are printed on new lines. So this is how you give. Now something must be very annoying, which is this std. Now for any functions, for most of the functions, you have to write std double colon. This is very annoying, right? This is where something like using namespace comes in. So we say, hey, can you use the namespace std? So basically what this means is, if you're not giving anything, if you're not stating anything, it eventually says, since you have written using namespace std, again, you don't have to dig deep. The moment you say this, the program always uses std for all the functions. Yes, always uses std for all the functions. Now, if you compile, it prints everything. Now it looks a easier task, isn't it? So this is how you can easily write. Okay, now let's quickly have an input. Imagine you want to take an input. So imagine I want to take an integer as an input, int x. So this is how you take an input. It's a scene of x. Scene means input into this variable. Input into this variable. Now imagine in the input, I go across and I say 10. and I'll be like, let's print this x guy. So I'll be like value of x, and then I can go ahead and write x. So if I go and print this, you will see value of x is printed as 10. What happened? You printed this particular string, and then you said space, and then you printed x. So this x was taken from here. Got it? Now imagine if you want to take two variables as input. So if you want to take two variables as input, you can give it like this. And over here, you can give them in the same line the value of x, and then you can go ahead and say and y, and you can probably write this as back this one and this. So what happens is value of x and y. Now, do you need to give them in the same line? You can give them in different lines as well, and it will still run in the similar fashion. So this is how you can take any inputs. So what happens is the first thing gets into the first scene, the next thing gets into the next scene. So depending on how you are writing scene, line by line, everything gets into variables that you're initializing it with. Now you might be thinking, what is this int? Now there are certain things as data types, which I'll be talking about. But before moving into data types, now as I said, there are a bunch of libraries. Imagine you are taking string, integer, let's say a lot of other data types, or a lot of other libraries. Will you be writing hash include, hash include, hash include, hash include every time? No, it's going to take you a lot of time. This is where C++ says, hey, I've got something better for you. I say, can I write bits std C++ dot h? Now what it does is, it includes all the libraries, everything. Whatever libraries are there in C++, everything is included under this bits slash std C++ dot h. Now you might think, but Striver, in order to include so many libraries, we will be taking a lot of time. Yes, we do take a lot of time, but that is very negligible compared to the time that your program takes to run. So that is why it is okay to include bits slash std C++ dot h. Yeah, it takes a bit more time, but that is okay. Again, if you want to check out what are the libraries inside this, you can definitely Google this and you'll get all the list of libraries that are inside this particular directory. So this is what is the common skeleton of the code that we will be using to write any C++ program on the planet. So you have discussed the first thing, that is the skeleton of the code and the user input and output to a certain extent. We will be digging deep into this as we move forward. What is the next type? That is the data types. Now, we're talking about input and output. Now, if you're taking a number in, you have to store it somewhere in your program. That is the place where you store. That can be a data type. Okay, now imagine you're taking a number like 10, 12, minus 5. What will you use to store it? So there is a data type known as int, integer. Now this is how you can write comments in C++. If you give double backslash, you can write any comment. So integer, what does comment means? Those lines of code will not be executed. So this line will not be executed when the program is executed. So int is the data type. In order to assign anything to integer data type, you have to write the data type and then a variable name. Variable name can be anything. It can be Raj, it can be X, it cannot be a number. It cannot be a number. Okay, so it can be Raj1, that is okay. But it has to be something which has a character. So something like, let's say, I say X equal to 10. So this is how you assign something into an integer data type. But integer has certain restrictions. It can only store numbers from this range to this range. Beyond this, it cannot store. Beyond this, what will help you? Something like a long data type will help you. If you try to use long, it has a wider range. Same concept, you can use the same concept to store variables in long. If you want to take an input, this is how you take an input. If you write scene of X, the first number 10 will go into X. Okay, now what if you want to store bigger numbers than this? This is where something like long will come in. So if you're saying long, it will give you a wider range. Again, the same way, you can store it like this, or maybe you can go ahead and store a very large number as well. So usually we will be using these three things to store any type of integers between a certain ranges. Okay, now what are the next data types that we will be using? We were talking about integers. What if we have something like, let's say 5.6, something like this. So it is having something after the decimal point. This is where something like, we will be specifically using two data types, float and double. Again, they have ranges. Depending on the range that you use, you'll be using float or double. The ranges are visible on the screen. So we can use something like float. Again, same way. Float x equal to 5.6. Again, you can always store float y equal to 5 as well. It doesn't mean that, like, if I'm saying that it has to store decimal, it doesn't mean you can't store an integer. Now, if you go and say C out of y, like value of y, and then you say, okay, let's print this y. Let's see what it prints, okay? So if you see the value of, okay, it does give you an error. Okay, by the way, let's erase this because we have defined x twice. Okay, let's now compile this. You see, it is getting printed. Similarly, if you want to define this as double, it's still okay. If we define this double, an integer can also be stored in a double. Okay, so in data types, you have learned how to store numbers and numbers with decimal points. Now, what if you have a string or a character? How do you store that? So for that, what we will be using is something like a string and get line. So you have to learn these couple of things. Okay, now imagine I write hey string. So this is an entire string, and the same way I'll say string s, and I'll say cn of s, and I'll say cout of s. Okay, ideally what should happen is this entire haste driver should go inside this string and this should be printed. But let's see what will happen. If I run this, you will see just hey being picked up. And if you want to pick up striver, what you have to do is you have to define two strings. If you want to define two strings in a same line, comma will be the thing, or you can go ahead and say string s2, and over here s1, and then you can say s2, and over here s1, and then you can give a space and then s2. So what will happen is, now if you do, first s1 is picked up as hey, then s2 is picked up as striver, then both of them are printed with a space, right? So if you're saying string, then what happens is it only picks up anything before the space, and after the space it's a new string, so you have to again give a cn. Now in case you want to take everything together in a string, how do you do that? In order to do that, you have to probably define a string, and then you have to use something like getLine. Inside the getLine, you have to write cn. What is getLine? Again, do not need to dig deep. It's an internal function. You have to write cn, and then you have to give this variable over here, and then you go ahead and say cout of str. So what will happen is this getLine will take the entire line and put it into the str. And now if you print, you will see this hey driver is printed, or maybe hey driver I am school. And if you print this, you'll see the entire line is getting printed. But if you go to the next line, hey Raj, will the entire line be picked up? Let's run this. No, the next line is not picked up. Only this particular line is picked up. So the moment you click enter, the next line will not be picked up. So it just picks up till the line break. So string and getLine is used to take any of the string. So you've talked about string and getLine. Now it's time to talk about character. Now there are 256 characters in English dictionary. So character can store all of them. Yes, character can store all of them. So imagine if you have something like an h. So you can just go ahead and declare char ch, and you can take cn of ch, okay? And then you can say cout of ch. So what will happen is this h will go inside this and it will be printed over here. If you want to declare a character, you can go ahead and declare this as G. So single quotes is what will be used to declare a character. You can also declare it as string, but usually string will be within double quotes. That is also okay. But string ends up taking much more space. That is why if it's a single character, we tend to use something like a char. So, okay, do we have, okay, so these are the data types that I have used till now to solve all the problems in DS Algo. Did I require anything else? No. In case I've required for a single problem, like one problem here or there, I have done a Google search and I've used that. But I can assure you that if you know this, that is more than enough. Now you must be having a lot of questions. Trevor, if we have something like a 10 and that 10 can be stored in all the 3 or all the 5, why can't we use simply long or maybe double? Now the thing is, everything takes up a certain space in your computer. Now you can't be like, you can't use long to store 10. That will not make sense because it will end up eating up a lot more memory space. So integer takes a certain memory, long does take a certain memory. So everything will take a certain memory. So depending on that, we decide what to use. Now, integer has a range. Now, those numbers you can't remember. So what I usually do is I keep a rounding of number. Like I know integer will be from minus 10 to the power 9 to 10 to the power 9, like rounding off. Long will be minus 10 to the power 12 to 10 to the power 12. Long will be minus 10 to the power 18 to 10 to the power 18. So whenever there is something as 10 to the power 13, I switch to long. Don't have to remember exact numbers because you will not remember that much when you go on the longer run. Okay, so that is how I usually do it, and you can also follow the same process. So we have completed data types. Now the data types that I've covered, that are more than enough. Again, very crucial point. Do not dig deep, because eventually when you keep on coding, you'll learn everything. Okay. First, third thing, if else statements. Let's go. So till now we know the skeleton of the code. We know the data types. Now let's write some program. So the first program is write a program that takes an input of age and prints if you are an adult or not. So the skeleton is something which I've written, and this is the program. So let's break down the problem. It states write a program. Maybe I've written the skeleton that takes an input of age. Now you know one thing. Age will be what? An integer, 18 or maybe double. Imagine the age we are talking in terms of integer. And we know you're called an adult when you're greater than 18, correct? So imagine I enter something like 19. In that case, you have to print adult. Imagine I enter something like 17. You have to say not an adult. If I print 18, adult, right? If I print 10, not an adult. So I need an age. So maybe I can go ahead and say, okay, int age. So you need the age from the user. So cin, hey, give me the age. So maybe if I give the age over here or something like this will be picked up into this age. Now, this is where something like if else statement comes in. What is it saying? Print if you are adult or not. Can I say if you are greater than equal to 18, then I can say you are an adult. You are an adult, yes. Or if you are lesser than 18, you are not an adult. Can I say this? So this is something which you are speaking in very layman terms. If you want to convert this into programming language, this is where something like if else comes in. There is something as if, this is the block, and there is something like else. This is the block. So inside this, you perform stating, okay, if something happens, perform these lines of code. If that thing doesn't happen, go and perform these lines of code. Okay. So I'm saying if the age is greater than equal to 18, then go and perform this. And if it is not, go and perform this else. Very simple. And if I'm saying if the age is greater than 18, what am I doing? I'm saying print you are an adult. So the print line is very simple. You are an adult. Simple. Like you can just capitalize this. And if you are not, then go ahead and print this. You are not an adult. So basically, first line says 20 will go on to age. Then it will say 20 greater than equal to 18. Yes. We'll go inside this and print this. So let's run this and see what happens. So I'm taking 20. Yes, you are an adult. If I take 15, what will happen? It will say you are not an adult. Simple. Now, this is the basic if else statement. Now, you can modify this as well. Now, imagine you are saying, for an example, you are saying 18 yes, 18 no. I can also write this as this. This is okay. This is saying age is greater than equal to 18. If not, go to the else, but only get into the else if the condition satisfies. Over here it will, but eventually you will learn. Is it mandatory to write an else statement always? You can omit the else statement as well. So if you omit the else statement, what will happen is the 15 will be taken as the input and the if will not be executed and it will not find an else. So nothing to be executed, completed. So it is not mandatory to have an else statement. If you're having a if, it is not mandatory to have a else statement. So coming back to the else if, what happens if you're giving 15? The if is false. It states no, not greater than equal to 18. So goes to the else, but else says, wait, before going into me, you have to pass my condition. And my condition states, are you lesser than 18? and it says, yes, I'm lesser than 18, so I will go. If this was lesser than 10, see what will happen. You're giving 15, I'm taking 15, false, goes to else, and else condition says lesser than 10. When I run, it doesn't runs. Why? False. Again false. No execution. But the moment you give something as 9, see what will happen. The moment you give it 9, it prints Y. Goes here, false. Goes to the else, and he says 9 lesser than 10. Yes. Goes ahead and prints this. This is how something like a if and an else if block works. Got it? So let's now move on to a complex problem so that you can understand the conditional statements in depth. So this is how you can write the multi-line comments. Since I had an entire problem statement, I put them under multi-line comment. So backslash asterisk is how you can do it. For single line, it is very simple, doubles backslash, but front slash or backslash, whatever you call it. So this is how you can write the multi-line comment. So the problem is very simple. A school has following rules for grading system. Below 25, grade F, 25 to 44, grade E, 45 to 49, grade D, and so on. So your task is to ask user to enter marks and print the corresponding grade. Okay. So what is the first stating? Get the marks. So imagine I have to take the marks. So this is how I'll take the marks. This is something which we know. What is the next line? Below 25. Very, very importantly, below 25. So I'm saying if the marks are below 25, can I say the grade is for sure F? That is something which I definitely know. If the marks are below 25, I know the grade is F. If the mark is between this, can I write if the marks, now over here there are two conditions, should be from 25 and should be till 44. So can I say should be greater than 25? And if you have multiple conditions, if you want to satisfy multiple conditions, you say and marks lesser than equal to 44. This is how you satisfy multiple. First condition and second condition. And then you say C out E. Similarly, you can go ahead and write all the if conditions. So what I've done is I've written all the conditions. You see, all the conditions are written. Let's take the marks as 85 and see which condition is getting executed. So if you take the marks as 85, this is executed. If you take something like 24, let's see what is executed. You see, everything is running fine. But is this the correct way to write? No. Why? What happens is the marks is going and checking this if. Imagine the marks is something like 86. This if is false. Again goes and checks this. 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 False. So at the end, this is executed and A is printed over here. Okay. Now imagine if I give 24. What will happen? F will be printed, right? So this is executed. True, prints F. But then goes ahead. This is executed, false. This is executed, false. Executed, false. Executed, false. Executed, false. Only this was true. But all the ifs got executed. Hence, you ended up taking a lot of time. This is where, yes, this is where something like an else if comes in. So if you write else if, see what happens. Else if, you can write else if, you can write else if, you can write else if. So if you write else if, what will happen is, if 24 is true over here, none of these lines will be executed because it states else. It will never go there and it will not be executed. So you'll be saving a lot of time. Previously, in every if was executed. So this is why else if will be written. Now, another thing. You're having 24. Imagine if you have something like, let's say 30. So you're saying if not lesser than 25. So this is false. This is definitely false. Do you need to check again for greater than equal to 25? Because you are sure that it is not lesser than 25. You are sure because this is false. You are sure. So it will definitely go here. So you don't need to write this anymore. You don't need to write this anymore. Because if it is lesser than 25 and if it is lesser than equal to 44, that means it is between 25 to 44. It means that, and if this is also false, that means it is not lesser than equal to 44. So you can also omit this. See, you can also omit this. Same way because 49 is checked, 59 is checked. So you can omit checking greater than 60 and eventually you can do this. So you saw how easily I trimmed it down. This is how you will be trimming it down. So if I now deal, you see 30 is printing E. If you give something like 48, that will be printing D. So every line is executed properly, because if all these are false, which means the number is never lesser than 49. And if it is true, it means 50 to 59. Super simple. Got it? This is how you trim down multiple conditional statements and multiple if statements. So this is the last question for conditional statements, and over here we will be learning something about nested if else. So the problem is pretty simple. Take the age from the user and then decide accordingly. So if the age is smaller than 18, you can print this, and all the conditions are given to you. So something we know for sure is we need age, right? So we can take the scene of age. Now we know something, if age is smaller than 18, then we got to print something like not eligible for job, right? This is what we will be printing, correct? Then it states else if the age is greater than equal to 18, you will be printing eligible for job. If it is greater than equal to 18, you'll be printing eligible for job. Okay. But if it is somewhere between this, which means anywhere between this, it's eligible for job. But anywhere between 55 and 57, eligible for the job, but retirement soon. That is what you have to print. Got it? So what I will go ahead and do is, I'll say, okay, else if age is greater than 18 and age is lesser than equal to 54, and you can say see out eligible for the job. So I'll just copy paste this and print. Perfect. Again, do you need to write greater than 18? No, because if this is false, it is definitely greater than equal to 18. So just remove. Simple. Or else, if this two are false, that means it's not lesser than equal to 54. So you just need to check if it is lesser than 57. If it is lesser than 57, you go ahead and print C out of this statement. Very simple. You go ahead and print this statement. Super simple. And if it is not lesser than equal to 57, it's greater. And if it is greater, it will always go to else. It will always go to else. And if it is going always to else, you can always say C out retirement time. Very simple. This is how you can easily write it. So if, else if, and the last can be written, you can write the conditional of greater than 57, or you can just leave it as it is. So imagine I give you something like 55. Let's see if it is working fine. 55 says eligible for job, but retirement soon. Now, if I want to convert this into a nested if, just to explain you nested if, something to figure out. So over here, it states 18 to 54 is eligible for job. Even 55 to 57 is eligible for the job. But retirement is soon. That's the extra addition that I have to tell the user. Just retirement is soon is what I have to tell the user. So can I write something like this? Hey, wait. Can I write 57? And can I omit this? So if I omit this, what will happen? For everything lesser than equal to 57 and greater than 18, I'll always say eligible for job. Inside this, can I say if the age is greater than 55, because I know if it is coming inside, it's greater than 18. That is something I surely know it's greater than 18 and lesser than 57. If it is going inside these blocks, and it will definitely print eligible, because I know for everyone from 18 to 57, they are eligible. But if the age by chance exceeds 55, and I know it will always be lesser than 57, then only I go ahead and say, hey, if it is exceeding, then can you go ahead and say retirement soon, but retirement soon. That is the extra thing that you need to print, right? But retirement soon. So this is how you can also write it. So this is what you call as nested if. So what happened was, you just took out the if from here and you put it over here. Does it save time? No. I just wanted to tell you that inside if, inside else if, you can also write conditional. Inside this if, you can go ahead and write another conditional. So it can go nested. These are called nested if else statements. Inside if, one if, so nested ifs. Got it? So you can write conditions according to your choice, and eventually when you go across time and you solve tougher problems, you'll see that you'll be writing multiple such conditions. Okay, so we have completed the if else statements. Now what's the next thing? We'll be completing the switch statement. We are talking about switch statement, so we will be taking this problem in order to understand the switch. It is similar to if else. We generally don't use switch that much, but it is handy to know the switch statements as well. So what is the problem stating? Take the day number and print the corresponding day. For 1, if they're giving the day number as 1, you have to print Monday. For 2, you have to print Tuesday, and so on. For 7, you have to print Sunday. So they'll be giving you a number between 1 and 7. So the syntax of switch is super simple. So you take the, let's say, the number, the day number, same day. So whatever variable you're taking, on that you have to write the switch. So it's kind of a switch. So you say switch day. Okay. And then you open the braces. So on the basis of the day, the switch will be triggered. Okay. So you know the switch will be between 1 to 7 because they're saying the input will always be between 1 to 7. So you write case 1. Okay. So case, and then if this is an integer, you write the integer. If this was a character, then you could have written a character like this. Whatever is your switch, you write the same switch over here. So case 1 is the switch. And then you go ahead to write case 2 is a switch. And then you go ahead to write case 3 is a switch, and so on. So what I've done is I've written down all the cases because those are the cases. Now I know one thing. For case 1, I have to print what? I have to print C out of nothing but Monday. So go ahead and print Monday. Similarly, Tuesday, Wednesday, please print out everything. So this is how you'll write down all the cases. In order to understand switch better, let me give you an example. Imagine you enter 5. So what will happen is, it will take the input as 5. Switch says 5. It will directly go to case 5 and print Friday. But see what happens. It prints Friday, Saturday, Sunday. So it went to the case 5 and it executed all the corresponding cases. But it started from case 5. Imagine you give 2. It will start from case 2 and it will execute everything. So how do you prevent this? Something for sure is when you trigger 2, it reaches here. It doesn't execute this. So once it reaches here, there is something as break statement in C++. What break does is, it breaks out of all the conditional statements that you have written. So over here, the cases are conditional statements. It will break out. The switch is a conditional statement. So it will break out. See what will happen. If you give a break everywhere, so make sure you give a break everywhere after every condition. If you give a break after every condition and after all the cases are executed, and if I just give a cout to check, see what will happen. And I'll also give a cout to check after all the cases have been executed. Okay, check inside switch. So ideally what should happen is, 2 means Tuesday should be executed. Break means all the cases. And as I said, all the conditions. This will also be broken out and it will reach the line number 36. See. So if I give it, it reaches the line number 36 check and not over here. Very important to understand this. Okay. Now there is something as a default. Imagine I give you something like 19. Then what happens? So if I execute, if I give 19, none of the cases gets executed because there is no case as 19. So you can probably give something as a default case. Imagine none of the cases is executed. Then it falls back on the default. So if you give something like as 19, it falls back on the default and you can say as invalid. So this is the last executed step. So you don't need to give a break because after this, it automatically breaks out. So imagine if you give 19, what will happen is it will go ahead and say invalid and then go over here. If you don't give a break here, and if you give something like cout invalid check, can you guess what will happen? Because you're not giving a break. See what happens. Invalid, and then the last line of the switch is also executed. But the moment you write break, it breaks out. It doesn't execute this. So whenever you write break, it will take you out from all the conditional loops or all the conditional braces that it has above it. Got it? By the way, we will be using break a lot of times in the upcoming problems. So your concept about break will get more and more clear as we will be solving problems in the upcoming lectures. So this was about the switch statement. It is kind of similar to if else. So that is why people tend to use if else, because that is more readable. But yeah, it is handy to know switch. So just in order to know, just know it. So we are done with the switch statement. Now we will be knowing the basics of arrays and strings. Now arrays will be covered in depth. Over here we will be covering 41 problems, and strings will be covered on the upcoming lectures. But as of now, we just need to know the basics of arrays and strings. So let's start with arrays and strings. So when do we use arrays is a very big question. When you have a similar data type being stored multiple times. For an example, over here I'm giving you four datas. So you can see that these are integer data types, right? 3, 4, 5, 7. These are integers. So one of the ways you can store them is, by the way, template, yeah. One of the ways you can store them is A, B, C, D. And you can say C of A will take 3. Then you can say B will take 4, C will take 5, and then D. So apparently all these four integers, one by one, will go into these four variables. But imagine if you have 50 data. You can't have 50 variable names, because to name 50 variables, it's going to take a lot of effort. That is where something like an array is used. So what I say is, I know the entire data is of similar type, which is integer. Why can't I define an array? So what I do is I say int array of, let's for an example, say 5 numbers are there. Int array of 5. So what this does is, I'll give you a diagrammatic representation. This creates an array of size 5. Now this size 5 array looks something like boxes. Every box can store an integer. The 0th index can store an integer. The first index can store an integer. The second index can store an integer. And all the index can store an integer. What is an index? This first guy is referenced by 0th index. The second guy is referenced by first index, one less. So if the size is 5, the last index will be 4th. So this is how an array will look. And depending on the data type that you have given, every box or every location of that array or the index is gonna store an integer. If you would have defined it as, let's say, long, it would have stored long in that index. If you would have defined it as character, it would have stored character in that index. So over here, our use case is defining it as an integer. So I will define it as an integer. Now I'll say Cin of array of 0, Cin of array of 1, Cin of, oh my bad, I'm taking the other one, array of 2. Then I'm say array of 3. Then I say array of 4. So what happens is, the 0th index takes 3 and everything is stored. Now imagine I want to print 7. So what you can say is cout of array of, where is 7 stored? 7 will be stored at the 0th index, first index, second index, third index, second is 3. Yes. And if you print this, let's see if 7 was stored. You saw. So what happened was, these 5 numbers went in and were stored in these places consecutively. So when you access the third index, it means the fourth element got accessed and you got the fourth element. Can you modify these? Yes, you can. If you want to do operations on them, you can. Imagine I say array of 3. Can you go ahead and add yourself 10? So if it adds 10 to itself, 7 should become 70. Let's see if it becomes. It does. So you can modify. So it is exactly as the data type. You, like, whatever you wish to do, you can do it. If you want to do something like, hey, array of 3, replace yourself with 16, change your value to 16. It can as well. You can do whatever you wish to with this particular array. You can treat it similarly to an integer data type. Got it? So this is how you can store similar data like together. And the container used is array. There are multiple other containers as well. I have talked about that in the C++ STL video. You can definitely check it out as well. So we got to know what is an array. And the most important thing is, everything has to be of a similar data type. You can't be saying 7.7. If you say 7.7, what will happen is, since you declared this to be an integer data type, this 7.7 will trim itself to an integer and hence it will be stored as 7. Got it? If there is a double data type, maybe you can store double. And if you say double, then 7.7 is stored. Whatever data type you give, that has to be constant for all the elements. That is the key point. Okay. So that was about the array. Now, where is the array stored? We know it is 0th index, first index, but the entire thing is taken and stored in a memory location. Yes, the entire thing is taken and stored in a memory location. So this guy, 0th index, is stored at a particular memory. And that memory can be of any address. That address is very randomized. I cannot say that it is stored in, let's say, India. Like, there is nothing like at this memory address it is stored. Throughout the CPU, it can be stored anywhere. Now, the first index, now that one I can definitely say will be stored right after the 0th guy, right after the 0th guy's memory address, right? The consecutive one. Then the second guy will be stored right after that. So the 0th guy, we're not sure, but we are sure about the next guys because they will always be in consecutive. So remember, array elements are stored in consecutive memory address, but I'm not sure where the first one will be. It can be at any randomized location. Very, very important point to remember. But will it be required in DS algo? I don't think so. But it is a point which is important and you should keep in your mind. So till now, we did learn about the 1D array. Now we will be learning about the 2D array. What is a 2D array? Again, I'll be giving you very basic idea about 2D array over here. Eventually, when we move across the playlist, we will be learning about 2D array in depth. If this was declared, this was something like 5 guys or 5 boxes indexing from 0, 1, 2, 3, 4. Correct? Now, the moment I say I need 5 boxes, but I need them 3 times, I'll add 3. What it means is I'll have 5 boxes. If I show you diagrammatically, this is what I'll have. 3, 1, 2, 3, 5 boxes. 1, 2, 3, 4. 3, 5 boxes is what I'll have. So this is what it means. This is the row number. We generally call this as row and this as column. And if I talk about the indexing over here, again the indexing starts from 0. And this is how the indexing goes. You see 0, 1, 2, and this is 0. So this guy is known as 0, 0. This guy is known as 0, 1. This guy is known as 0, 2. This guy is known as 0, 3. So this is how the naming or the row and column goes. If I say 1, 3, so here is 1 and here is 3. 76. The value will be 76. If I say give me the value at 1, 3, the value will be 76. Again, if you want to assign, like it will be like A1, 3 equal to, you can say 78. And then you can go ahead and say C out of A1, 3. We will be seeing the use of 2D matrix a lot. We will be solving a bunch of problems. Don't worry about that. So this will be array and this will be array. So if you go ahead and print this, you'll be seeing that we're actually getting 78 at this location. And for the locations that you have not defined, they'll be assigning themselves some garbage value. It can be any value. Like if you try to print 1, 2, you'll see it is having a garbage value. Like if you try to print it again, it will have different values. Every time you print, it has some garbage value that comes in from the system because you did not initialize. The only guy that you initialized was the first row and the third column in terms of zero based indexing. Very important. In arrays, we have zero based indexing. Okay. Where is 2D array used? It is used to solve a lot of matrix problems, a lot of graph problems, which you'll be dealing with in the future. Okay. As of now, just know this is what we know as 2D array. This is the row, this is the column, and it goes as row and column. That's it. That is what you have to keep in your head as of now. So in the STL video, I've talked about a lot of functions related to arrays, vectors, list, and a lot of other things. So you can definitely check that video after this one. So we have known about arrays in basics. Now let's talk about string. So imagine this is the string that I am having. String s equal to string. And now I want to access I. So the string also stores every character in terms of indexes. So s will be at the 0th index. So if you try to print something like C out of S of 0, what will happen? See, S will be printed. If you say s of 1, see what happens. T will be printed. If you say s of 2, you know what will be printed. R. So every character is stored at an index. And the first index is the 0th index. And what will be the last index? Whatever is the length. So can I say the length is, this is how you find the length. Length equal to s dot size, or there is another function as length which you can use. So if I say length minus 1, because I know the last index, because everything works in zero based indexing, the last index will be n minus 1. I know it. So if I print this, what will be printed? Driver R, because this is what happens at the last index. That's how you can easily access the string. If you want to change any value, imagine you want to say, hey, I'm not interested in this. Please make it Z, strives, and I do it. It gets changed to Z. So you can also change it. Remember, these are characters. Characters at every index. And characters when gets added makes up a string. So all of these are characters. You can't do something like this and expect this to work. If you do this, it will not work and it will give you errors. You see, errors. So since it is a character, you have to assign it with a character. So string is storing characters within itself. So if you know about this and the length function, eventually we will be solving a lot of string problems, and there you can easily get on with strings. So we are done with arrays and strings. Now it's time to do for loops and while loops. And as of now, I'll be talking about basics. Eventually, we'll be solving a bunch of patterns, And once you end up solving all these patterns using for loops, trust me, your logical thinking, your concept of for loops will be super strong. And then we'll move on to solving maths and everything using the for loops and while loops. And eventually, in the entire DSA, for loops, if you don't know for loops, you can't do anything. So please stay focused. So what is for loops? Why is it used? Imagine I say you, hey, print your name. So I'll be like, cout. Okay, what's mine? My name is Trevor. And I'll print it 5 times. Done. 5 times printed. Print it 500 times. 500? That's a lot. This is where for loop comes. For loop says, same line of code. Why do you want to write it again and again? I'll do it for you. So what for loop says is, hey, same line of code, right? Write it once. And then enclose it inside me. Inside me enclose it. And the for loop says, okay, my syntax is very simple. Say for, what is the variable that you want to go across? How many times you want to run? Put up a variable for that. I want to run it for 5 times or 500 times. What is the initial? First, I equal to 1. Variable declaration, I equal to 1. Variable declaration. This only gets executed for the first iteration. Only gets executed for the first iteration. Then condition at which I'll stop. The for loop will stop. The looping will stop. So I'll be like, the condition is 10. I'm saying, till I don't reach 10, I'll not stop. And at every step, I have to do something. If I don't do, I will forever stay 1. And if I stays forever 1, this condition will always be true. And if it is always true, that line of code will run. And it'll never end. This is where something like increment or decrement, your wish, comes in. And I say, this is the line that I want to execute. And I go ahead and write this line. Now what happens is, see what will happen. I'll tell you how it happens. Wow. 10 times, exactly 10 times driver got printed. What happened was, first initialization, I equal to 1. First time, I is 1. I lesser than 10, yes. Goes, prints. Printed, comes back to this line. I gets 2. Next, goes here. 2 lesser than equal to 10, yes. Goes here, prints. Goes again here. I equal to 3. After here, goes here. 3 lesser than equal to 10, yes. Prints. Then goes here. I equal to 4. Imagine this is 5 for an example so that I can explain. I equal to 4, prints. Goes again here. I becomes 5. Prints. Goes here, I becomes 5. Checks. Prints. Goes again here. I becomes 6. The moment I become 6, 6 lesser than equal to 5. No, no. Stop. So it will get executed 5 times. But if you try to print the value of I, imagine you want to print the value of I. Something very important to notice. If you print it like this, it will not be able to find I. Why? Because the scope of the I was declared inside this. So the scope, wherever you declare I, the scope is limited to that. So the other way you can do is, you can say I and you can write something like this. So you declared the I here and then you've initialized it here. So if you print I over here, see what happens. So if I print I, the last value of I is 6, where it got truncated. You can run the for loop in the reverse order as well. Something like, hey, maybe start from 5, maybe go on till, and maybe decrease it. So if you do this, and if you print the value of I, you can see the value of I. Oh, sorry, my bad. You want to print the value of I? Maybe go like this. Oh, sorry, maybe like this. And yeah, this should be perfect. See the value of I. 5 for the first, then 4, then 3, then 2, then 1, then 0. Got it? So you can write the for loop as you wish to. Is it mandatory that you reduce by 2? No. I want to run this for 5 times. How I run it for 5 times is my choice. I can be like 1. I can be like, I need for 5 times. I will go till 25. I will do I into, or maybe I plus 5. My choice. I can go like 1, 6, 11, 16, 21. My choice. That's my choice. No one is here to stay. How I run doesn't matter. How many times I run is what matters. This condition depends on you. What you need to make sure is, if you want it for 5, if you want it for 10, if you want it for 20, make sure the condition is written in such a way that it runs for that many number of times. That is the core concept of for loops. Do we have nested for loops similar to if? Yes, we do have. And the nested for loops is something which I'll be teaching you while printing patterns. As of now, this is what you need to know. Can we write if conditions inside the for loop? Yes, you can go ahead and write if. Any line of code can be written inside any for or any while loop. So this is how you write a for loop. Now, I want to convert this exact similar for loop. I'll just comment it out. I want to convert this exact similar for loop into a while loop. So the while loop does the same thing. The task is same. Whenever I attach something like loop, the task remains same. Executing some lines of code for some number of times. We do the same thing. And here, the only difference is the syntax changes. While executes like this, whatever is the condition will go here. And whatever is the increment goes at the end, goes at the last line. Whatever is the increment goes at the last line. Okay. And the initialization goes over here. First time initialization happens. While says 1 is lesser than equal to 5. Fine. Go ahead and do cout of Trevor. And if you want to print i's value, you can also check it out. So if I go ahead and do endl, you will see the value. See. Perfect. So what happens? Check, print, increase, check, print, increase. First check goes inside, increases, comes back, checks, prints, increases. Very simple. This is how a while loop executes. So this is about while loop. Now while has one more concept, and that concept is do while loop. Okay. Now what does do while mean? So can I say, if I keep I equal to 2 and I keep something like this, will it execute? The answer to that is no, because I is 2, the condition is false, never executes, goes to this, ends the program. So do while says, you don't know the condition, because when you're writing code in industry or maybe you're solving a problem, a lot of times the condition might be user dependent or you might have such use cases. So you always want one thing to happen, that is, you want your line of code to be executed minimum for one time. Minimum for one time. That is when you say, okay, if I want it to be executed for minimum of one time, I will write it something like do, and I'll put this condition for over here at the end. And then I'll be doing the same thing. I'll be doing the same thing. So what will happen is, even if the INDI is defined as 2 and the condition doesn't execute because it doesn't allows me, and then you end it with a semicolon. Even if the condition doesn't allows me, do says do it for the first. Go ahead, do it for the first, then increment, then check, then do. So if you say I equal to 2, see what will happen. Driver 2 gets printed. And then if you see the value of I at the end of the while loop, let's print. What will happen? The value of I was 2. You printed striver. I increased to 3. And 3 was lesser than equal to 1. And it got ended. But do will make sure the first time it gets executed, irrespective of what condition you are giving. So this is the basic, like you can define it here, you can define it before this, that is your choice. But this is the basic of for and while loops. So I can say this is the basic of for and while loops. Eventually, when we solve these amazing set of patterns, the concept of the for and while loops will get more and more into your head, and you'll be very strong in logical thinking. And eventually, you can apply for loops in maths, recursion, and all the other problems. Okay, what's the next thing? Functions, pass by reference, and pass by value. Functions is very, very important because we'll be using functions throughout. Yes, throughout. To solve any problems, we will be writing functions. So please make sure you understand functions in a proper depth. So let's start with functions. What are functions? Functions are a set of code which performs something for you. Now, if I want someone to do something for me, like for an example, if I want to order food, I can say I can deliver food from a food delivery app, and that will bring me in food. So you can say functions are similar. You want it to do something, you'll give it or maybe something, and it will do that for you. That is the role of a function. Why are functions used? Functions are used to modularize code. Now, a lot of times you'll be having hundreds and hundreds of lines of code, and it becomes very clumsy. So in order to modularize, because every portion of the code will be doing something, so that something will be put into a function. Okay, functions are used to increase readability. Now imagine you are writing code and you have like 1,000 lines of code. You know what every line is doing. But if someone from outside is reading your code, he might not understand. So what do you do is every step you put it into a function. Name the function in such a way that it is understandable what it is doing. Got it? And functions are used to use the same code multiple times. So if you are performing same, like if you're using the same set of code again and again, it's not good to write the same code again and again. So you can put them into functions and use the function. Okay, so I'll be showing you all these things. So there are basically there are a lot of kind of functions, but usually we do use like 4 kind of functions. One is the void function, the other one is the return function, the other one is where we carry a lot of parameters, the other one is where we do not carry any parameter. Okay, so non-parameterized functions. So let's talk about the first one, void function. The void function is something which does not returns anything. Very important, it doesn't returns anything. So imagine I'm saying print your name. You know that is easy. You'll come across and say, hey, see how, hey Striver, printed. So you know one thing, if I'm saying hey Striver, that is something which I know. But if someone is coming from outside and is reading this, like, what does see out mean? I don't know. I don't know what see out means. This is where readability comes in. If I do not know C++, I will not be knowing what see out means. That is where we say, okay, let me write a function. So what function I'll write is, I'll say, okay, void. That is the keyword. It means it will do something, but it will not give me something. It will not give me something. And then I'll write the function name. I have to print the names. So I'll just write print name. And in that, I'll put this. So it did not return me anything. It's a void. It will never return you anything. And this is the function name. And this is a non-parameter. It will not carry any parameter. Whenever you enclose it within parenthesis and there is nothing inside it, it doesn't carries a parameter. So it does this. Now over here, if you just run this will not be executing this function because this is outside the main. You know the skeleton of the code is executing anything that is inside the int main and the function is outside. So what you do is you say print name and you execute this. Now what will happen is int main will come, print name will happen, and then it will go across and execute the line of code. See, hey driver executed. Now imagine I say take a input and print the name. So you'll be like, okay, this is the line of. Maybe I'll take int name and I'll say scene name. And I want to print this name. I want to say, hey, this name. And this name might be Raj. So if I say just print name, what will happen? See, it'll still print hey driver. I want you to print hey Raj. This is where something like a parameterized void function comes in. I know I have to take this name. Maybe I'll pass this name. So I'm saying print name, take this name. Print name will say, okay, please give me this. What, oh, by the way, string. What is the data type of this name? It says string. I'm passing the name, but it gives you red. Why? Because this guy is not taking any parameters, but I'm giving it name. I'll say, okay, what are you giving me? You're giving me a string. I'll take the string. I'll take the string. When I've taken the string, now I'll say, hey, can I say name? See what will happen. This function took this name and printed. Now this moment when you say Raj, see what happens. Hey Raj. If you say Striver, it will say, hey Striver. If you say Aman, it will say, hey Aman. Simple. This function, what is the function of this function? Takes a name and prints a name. Very simple. It can take any name. So you can maybe use it again. See string name 2. And you can maybe take name 2 and you can say print name. See reusability of codes. I'm using the code again and again. And I can say, okay, Aman and then Raj. And then maybe over here, let's give an endl so that every time it says hey, new line, see what happens. Hey Aman, hey Raj. Now, had you written this line, you'd have written it again and again and again. But this is where reusability of code comes in. Now, this is not under, like, you can maybe put it under for loop, that is okay. But if there will be cases where you cannot use for loops, but you have to use shuttle lines of code again at different places. That is where something like a function comes in. So I can call this as a void function and as well as a parameterized function. So you have understood void, you have understood parameterized, you have understood non-parameterized. Okay, now the next question that we will do is take two numbers and print its sum. So what I'll do is I'll take two numbers. The two numbers are on the input. So let's do this. id num1, num2. Let's take the two numbers, num1 and num2. Now I'll say cout of num1 plus num2. Or maybe you can do it something like id num3 equal to num1 plus num2. I can say let's print num3. Perfect. What will happen? 5 plus 6, 11 will be printed. Imagine this addition operation. You have to do it multiple times. Imagine you're writing a program for calculator. A lot of times addition operator will be done. Can you always just keep on writing plus, 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 plus? No. That's when you have to modularize the code. You have to make it readable. So one thing you can do is, like, you can say, okay, what is this doing? I'm giving two numbers and I'm saying sum. It will always have two numbers to take. So if you're trying to write a return function, it will always be like integer sum. Again, the name of the function can be anything. It always takes two numbers. So there can be two parameters. There can be any number of parameters, multiple data types. You can have something like char c as well. That is okay. Num2. This is num3 equal to num1 plus num2. And you can say return num3. And over here, what you can say is, I've taken the inputs and I can say the result will be, I'll say the sum guy to take num1 and to take num2. So the sum guy is called. So what happens? Let's understand the line of executions. So what happens? Let's understand the execution. So the main says, okay, num1, num2. Take it as input. 5 and 6. 5 goes to num1. 6 goes to num2. And then I call sum. This is where the program stops. The The program stops at the line 21. Program stops at line 21. And now it goes to line 13. At 13, it is taking num1, which is 5. It is taking num2, which is 6. So 5 and 6 are passed over here. And it states 5 plus 6. And then num3 takes 5 plus 6, which is 11. And it says return the value. So it returns 11. And this function gives you 11. Because this function was called, this function gave you 11. Now that 11 goes and gets stored into res. And then the line 21, which was stopped, will be executed. And then this line 22 will be performed. What is the value of res now? It is 11. So it gets printed. So whenever you're calling a function, first the function will be executed. Whatever value the function gives, if it is a return, that will be stored here. Then the remaining lines will be executed. On a function call, the flow will go to the function. The flow will go to the function. Got it? This is what you call as a return function. This will return something. You could have done it as a void function, void parameterize, and you could have done cout now. That is also okay. In that case, you don't have to do this and you don't have to do this. Different ways of writing code. A lot of people write code in different ways. You can try it as you wish. My main idea is to teach you what are functions, what different kind of functions you can have. Now remember one thing, if you are writing as this and this can be anything. This can be an integer, can be a double, can be a long, can be a string, can be an array, can be a vector, can be a list, can be anything, And you will see eventually in the DSA playlist, we will be writing functions where we'll be returning vectors, arrays, 2D arrays. There'll be a lot of things returned from here. And we will learn throughout the course. So please make sure you watch all the videos of this playlist because I'm going to go in super depth. Since we're talking about functions, let's take these couple of numbers again. And there are a lot of internal functions. Remember, at the start I said there is something as math.h. So there is an inbuilt function which says give me minimum. And if you write min and you give them num1, num2, and then you print minimum, see what will happen. The 5 is the minimum. Similarly, there is max as well. But there are a lot of inbuilt functions as well. Now, these functions are similarly written. So if you have to write a max function, how will you write? It will be very simple. It will be like num1, num2. And I know if I'm looking for max, if num1 conditional statement greater than num2, I can say that my max is num1. So, right? Or else I can say is my max is num2. Now there is something, you cannot name the function with the same name. So make it max, okay? So because inbuilt max function exists, so you have to give the function such a name that the inbuilt, there is no such inbuilt functions. There cannot be repetition of function names. Okay, so max, now, will it work? It should, because data type returns. Let's see, will it work? It does return, okay? Now, for an example, let's omit this line. For an example, just for an instance, let's omit this line. This is an integer. This has a return statement. Will it work? No, it didn't. It did throw some random value. Why did this happen? Can you please tell me why did this happen? The reason this happened was, let's understand one thing over here. What did I say? I said number 1 greater than equal to number 2. So 5 was greater than equal to 6. No. So there was no if. Since this if did not execute itself, by the way, since there is one line, you can always write it without braces. Since this if was not executed, because I was stating is 5 greater than equal to 6, and that was false. So the if never got executed. And since the if did not get executed, the return line was not executed. And since the return line was not executed, this function was looking for a return line. It was looking for a return line and it did not find one. Thereby, it did give you like garbage stuff. So the program did not compile properly. It's very important that if you are writing an int data type stating that it will always have a return, you make sure you write a return. That is very, very important. Every function which with a return data type must have a return one, right? Make sure you do that. So we did learn about functions, but in the bracket it is written pass by reference and value. Let's understand what that means. So let's just take a number just in order to understand and do something. And we write a function, do something, and pass the number. Okay. And we go over here and write void. You know, this is a function. So write do something and take this number and maybe print it. And go ahead, change this number, let's say add 5 to it, again print it, and maybe again add a 5 to it, and again print it. So what will be the expected value? I'm sending 10, so 10 will be printed, then plus 5, 15, then 20. So ideally it should be 10, 15, 20. It is. But what did I say about the execution? How does the execution works? So it is like the first line is executed, then it calls it. So it goes here, this is executed, this is executed, this is, then this, and then the line 21, then the 22, then ends at 23. So ideally, if I print it here, what should happen? Ideally, according to you, number was 10, it went here, 10, 15, 20, finished, 21. At 21, it should be again 20 because the last value was 20, so it should be 20, right? Let's do. We run this. 10, 15, 20, 20 till here. But the moment it came to the line 21, the value was 10 again. Why? This is what we call as pass by value. What happens is when you call functions and you pass number, it goes by value. A copy goes. The original number did not go. The original number did not go. This original number must be somewhere in the memory. That original memory did not go. What it created was, it said, you are 10. Let me create a copy. Send that copy. I'm not sending original. This guy took the original. He said, you're 10. Copy. Take the copy and give it to the function. And the function took the copy, did everything with the copy. So he modified the copy. So since he modified the copy, the original value still stayed the same. This is what we call as pass by value. Okay, this does work with everything. Like let's assign string s equal to Raj, and imagine you pass the string s, and let's omit this, and let's say string s again. And over here, assume you say s0 equal to, instead of Raj, I say Taj T, and I print the string s. And over here also I print the string s. So ideally over here, if I'm changing s0 to T, Raj will become Taj, right? And then when it comes back, s is again printed. So what should happen? Yes, first it got changed, but since I did not pass the original, I passed the copy. Since I passed the copy, what happened was only the copy got changed and the original still stayed the same. This is what we call as pass by value. Now, there is something as pass by reference. What is this pass by reference? I don't want to pass a copy. I want my function to make changes on the original one. That's when you just attach an and to it. If you attach an and to it, it takes the address. So whatever you're sending over here, it takes the original and sends it. So this string, whenever you say s, it actually is dealing with the original. So let's now compile and see. So if you compile and see, you see it changed here and the same prevailed over here. This is what you call as pass by reference. Understood? If you're passing like this and sign will say that, okay, get it from the address, get the original value. Okay. Now this pass by reference can be written in a lot of other ways, but I personally feel the other ways are very, very confusing. The easiest way is just attach and sign, and that will make sure that it is passed by reference. The original value is passed. So if you want to pass the integer, Similarly, you can do integer num equal to 10, and you can pass a num here, and let's print the num here, and again take int. You can just pass the num here, and you can go ahead and say, let's do the same thing. Cout of num and l, and over here you can say num plus equal to 5. Again, you can say cout of num and l. Again, you can say num plus equal to 5, and again you can say cout num and l. Okay, so let's do. So if I run this, what should happen? See, the value got updated in the function 3 times, and then still the same value prevailed. Very simple. Now, a thing that you have to keep in the mind, imagine you are declaring the array. So do you remember declaring the array? Till now you were declaring the array like 5, and imagine there are like 5 values, 10, 7, 12, 13. Till now, all these values you were kind of taking like cn array of 0, cn array of 1, cn array of 2, cn array of 3, cn array of 4. This is how you took, and eventually you were printing it array of 0, array of 1, and going on array of 2, and so on. You just printed it like this, right? So if you run this, you saw all the values were getting printed. Like you can put a endl in order to get a clarity. Over here also you can put an endl. Okay. So if you just put an endl and run, so yeah, the first 3 values are printed. But is this a good way? Because there might be 500 numbers. What did you learn? Looping, array. Let's combine them. Yes. How many? What are you taking? 0, 1, 2, 3, 4. Can I write something like this? 0. I know I have to go till 4. Okay. I know how to do this. I definitely know this. Can I say cn array of I? Can I do this? Can I do the cn of array of I? What will happen? What's the first value of I? 0. So 0. Array of 0 will get in. So 5 will get in. Then what's the value of I? 1. So 10 will get in. Array of 1. Right? And then what's the value of I? So if you try to print the value of I, if you remember for loops. Sorry, my bad. See what will happen. The value of I is 0. So array of 0 is taken. Next, the value of I is 1. Array of 1 is taken. Next, the value of I is 2. So array of 2 is taken. And similarly, it takes everything. Perfect. If you want to print it, quite simple. Same way, run a for loop. You want to print everything. Array 0, array 1. Why do you want to write everything again and again? Just write cout. Give like this. Maybe put up space. And just see. Everything got printed. So I combined array, loops, and everything. Now, a question comes up. Passed by reference. I said include and to everything. But this doesn't work for arrays. Arrays are generically passed by reference. So if you write this is how you pass an array. So imagine this is the array I took as an input, and I said do something. And I said, can you please take this array and maybe the size of the array? And the size of the array is 5. So you can go ahead and maybe declare it in a better way. This, yeah, that's a better way. And maybe you can loop till n-1, or you can loop till n. That is your choice. You can do whatever you wish to. You can loop till n-1 because last index is n-1, or you can write lesser than. Both the conditions are meaning the exact same thing. So over here, I'll take everything. Now what I'll do is, I will go across to every value of, or maybe to just understand array of 0, I will go ahead and add plus equal to maybe 100 to it. And over here, I'll print array of value inside function, okay? And I'll say array of 0, please get printed, okay? And I'll say value inside int main after the function, okay? Value inside int main. Let's see if that got added. Do you see this? It stays 105. I did not pass it with reference, but array always goes with reference. So please keep this in mind. If you're passing an array, it will always go with reference. But apart from that, vector, maps, list, everything you have to pass that and sign to make sure that it is passed by reference. Got this? So whatever you do over here with the arrays, that will be definitely modified throughout. So with this, we learn functions passed by reference and value. Time complexity is the next one, which I'll be covering in the next video, because time complexity in itself is a very, very vast topic. And I want you to understand this in proper depth with a lot of examples. Why? Because this is going to be the most important topics. If you go for interviews, they'll be like, do it in the least time complexity. So we'll be doing that in the next one. And if you want to know more about C++, you can definitely watch out the C++ STL video. So if you have seen the video till here, I think you should definitely hit that like button. And if you've understood everything, please do consider subscribing to us, because I was going through our channel statistics. Nearly 50% of the users who watch these kind of videos do not hit that subscribe button. I know these are educational videos, but if you just click that subscribe button, that does motivate me to make such kind of videos. And yes, this is going to be a full-fledged playlist on data structures and algorithms. So do stay tuned. Follow me on Twitter, Instagram, LinkedIn, so that you stay updated about this particular playlist, and make sure you watch all the videos in this playlist. In case you haven't checked out other resources, you can definitely check out by diving deep into the playlist section of this particular channel. And you can also go through our Take You Forward website. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.